All right, so this is problem 1 from the worksheet I handed out. And I labeled a couple things here in terms of your summation notation for the final destination. So this is where we're ending up with something like this, where you have delta x, which is your base, and then f of x of k, which is your height. Now, I created a structure for this in your notes, and I want to create the similar structure here, at least on the worksheet, or you have 3 different sections. And I want to kind of work through each part so you know how to use this. So number 1, our first step here is to, I don't like that square. Number 1 would be to, it says find k, but it's really finding your delta x and writing your subscript notation. Okay. So I'll go ahead and copy this in for you. Alright, so you get a number line, and here's kind of where we start. Draw your number line out. My domain, I know, is from, let's go ahead and write this out, 2 to 4. And we have 4 right endpoint rectangles. Okay. So I'm going to start my number line from 2 to 4, and I'm going to divide this into 4 sections. So cut it in half, cut the half in half, I get 3. Actually, I shouldn't even jump that far. We should figure this out algebraically. So to do that, I'm going to do 4 minus 2, which is my difference, which is 2, which represents the entire distance here. And I'll write this in. Entire distance here is 2, and then I'm taking that 2 and I'm dividing it into 4 rectangles, and those 4 rectangles gives you 1/2, or 0.5, which is what we call our delta x, our change in x. So that means each interval is increasing by a value of 0.5. So 2.5, 3, 3.5, and then we end on 4. Okay. Now, we also want to put in our subscript notation for now, so we can use this for our limits later. X of 1, x of 0, x of 1, x of 2, x of 3, and then x of 4. Alright, so that's our step 1. Step 2 is to find x of k, which you're going to write in y equals mx plus b form, because it's a linear rate of change. So if we go back to our table, or not our table, but our number line, you will notice that your x values here are increasing by 0.5. Okay. So I will have y equals 0.5x plus, which is my rate of change, my y-intercept, which is 2, but we're going to rewrite this as x of k equals 0.5k plus 2, where, I annotate this on the sides, this is k and this is my x of k. So you're moving from your input to your output. In other words, if I plug in 0 to this, I do 0 times 0.5, which is 0, I add 2, I end up getting my 2 value. Alright, step 3. So now that represents the change with the x's. Step 3 is to find f of x of k, which is also known as your height. And we'll see why in a sec. Well, if you think about x of k, this represents your input, or your changing input. Well, when I plug in my input to f, I end up getting my output. And your output is just your height. It's the same thing. Okay? So let's see how this works with this function. So this function is very different than the one we did in class. It's an exponential. So f of x equals 1.6 to the x. Well, we're not finding f of x, we're finding f of x of k. which is actually just f of parentheses. We know that our x of k is equal to 0.5k plus 2, so it'll be f of 0.5k plus 2. So now if we have f of 0.5k plus 2, we're going to literally input this into our equation, because that's my new input. It's representing my changing x. F of x of k will equal 1.6 to the power of 0.5k plus 2. Which is now representative of my height. So let's go back to our summation. Let's write it. So if we're going to construct this summation, we don't have our limits yet, but we know that I need my base, which is my delta x of 0.5, which we'll highlight here. So here's my base. And you can see the 0.5x, or the 0.5 is from here. And then I'm going to multiply it by my height, and my height is, I'm going to leave this all in parentheses, 1.6 to the 0.5k plus 2. Okay, this would be like the whole thing. So you see I'm creating a separate structure for this height. So all of this is my height, because this is my f of x of k. All of this represents my height. Plugging that in. And once I have that, now I need to find my limits. Well, I'm dealing with right endpoint, and I have 4 of them. Let's look at our number line. Right endpoint, we don't deal with x of 0, because that would be left. We use 1 through 4. So my lower limit would be 1, and my upper limit would be 4. And this would be my entire summation. Okay, now I give you this structure so you can see the evolution from finding your delta x to really the hardest part of this is step 2 and 3, which is finding your x of k. And then you can see this is why we did all this work in chapter 1 with composition of functions. Then we're taking our input, plugging it into our function in order to receive an output, and that output ends up representing our height. Alright, this is pretty thick. Here's number 1. I want you to try the same process on 2 and 3. I think it will be super helpful for you. Make sure you also get the flipbook notes. So do this in the flipbook notes and then try 2 and 3 on your own.